Look around your home. Why is a cooking stove made of metal while the pipes carrying your water are made of plastic? This flowchart shows the starting point for every manufactured object. All engineering materials are divided into two main families, metals and nonmetals. Engineers don't just guess which one to use. They match a material's specific behavior to the exact demands of the job. Let's break down the metals branch first. We divide metals into two subcategories based on one key ingredient, iron. Ferrous metals contain iron. They are strong, magnetic, and if left unprotected, they will rust. Think of the heavy, durable steel used to make tools like these machetes. Non-ferrous metals, like aluminum and copper, do not contain iron. They are completely non-magnetic and highly resistant to rust, making them ideal for lightweight applications like these kettles. On the other side of our chart, nonmetals are split based on where they come from.
They are either natural, meaning harvested directly from the earth, or synthetic, meaning chemically manufactured. Natural nonmetals include wood and clay. Here, timber is being harvested for structural support, relying entirely on the properties it developed in nature. In contrast, synthetic nonmetals like PVC plastic are entirely designed and processed by humans to perform very specific tasks, like holding water without rotting. Whether you are digging a resource from a forest or mixing it in a lab, properly classifying what you have is the first step in ensuring your design will actually last. To make that design work, we have to understand a material's invisible properties. Let's clear up a common mix-up, the difference between hardness and toughness. Hardness is strictly the ability to resist scratching and surface wear. A glass window is incredibly hard. A steel nail will slide right off without leaving a mark. But hardness has a trade-off, brittleness. When subjected to a sudden impact, that same hard glass shatters instantly. Toughness is the exact opposite of brittleness. It is the ability to absorb a sudden blow without breaking. Rubber is relatively easy to scratch, but it is incredibly tough. Let's test this with conductivity. This diagram shows a cross-section of an electrical cable. Based on what you want electricity to do, what specific category of material belongs on the inside and what belongs on the outside? For the inside, you need a non-ferrous metal like copper because it's an excellent conductor. For the outside, you need a synthetic non-metal like plastic because it acts as an insulator, trapping the electricity safely inside. Selecting materials based on these exact behavioral traits is what separates guesswork from actual engineering. Let's build a safe swing set. The frame needs to handle dynamic loads, so we choose mild steel. Its ferrous properties provide high strength. For safety, seats can't be hard steel or brittle clay. We select thick rubber for its toughness. This chart shows the complete picture. By dividing the world into metals and nonmetals and understanding subcategories like ferrous and synthetic, you can predict exactly how an object will perform. By mastering materials and their invisible properties, you gain the ability to design safe, lasting, and useful tools for your community.